Tonight, you will be able to see spectacular and strong aurora in 49 of the 50 US states, sadly not including Hawaii, along with the majority of Europe, New Zealand, and even Australia. I will now take a moment to highlight where in the world aurora is most likely to be observed tonight, as marked by the areas between the two bright green polygons, while between the dark and light green polygons represents where auroras have a lesser chance of being observed but still could technically be seen tonight. Of course, these rough charts assume an observation time at the peak of the aurora's intensity and that this peak occurs during night rather than daylight hours. This aurora, as part of the strongest solar storm in 19 years, is expected to peak at between 6 and 9 am UTC time, which translates to 2 to 5 am Eastern Standard Time, 4 to 7 pm in Sydney, or 6 to 9 pm in Wellington. However, since auroras are only visible at night, the peak 3-hour intensity of the aurora certain to be generated will only occur between dusk and dawn in the United States, Canada, Greenland, Australia, New Zealand, and southern Chile. So, why is such an unusually strong aurora occurring? What physical damage could it cause? And why did we only just learn about this development? Auroras, for context, are created when highly charged particles released by the sun slam into Earth's magnetic field, which then flow down towards the magnetic poles. Once these particles reach the upper atmosphere, specifically in the thermosphere, they interact with various gas particles present where they shed some of their energy, causing the atoms to react and release a photon, producing light. Different gases and altitudes in the atmosphere produce different colors during this reaction, with oxygen often creating the color green at 100 to 300 kilometers altitude, red or pink being generated by oxygen at 300 to 400 kilometers elevation, or nitrogen at around 100 kilometers altitude, and purple and blue being generated by helium and hydrogen molecules. Auroras occur constantly due to our star's solar wind, but sometimes unusually energetic outbursts of material occur in what is known as a coronal mass ejection. The size and intensity of the ejection determines the strength of the resulting solar storm on Earth. In the case of the latest event, instead of 1, 7 coronal mass ejections, or CMEs, are all simultaneously on their way towards Earth, which was created by a grouping of sunspots about 16 times the diameter of Earth, or 127,000 miles wide. These coronal mass ejections occur at a variable rate in an 11-year-long cycle, which correlates with the flipping of its magnetic poles, varying from 1 a week to 3 a day. Currently, we are approaching the maximum amount of activity in the current solar cycle, which will peak most likely around October of this year. Around 5% of all CMEs the Sun creates strike Earth, translating to a rate of at least 10 a year. Most of these create small solar storms with limited effects, being rated as a G1 or G2 on a G1 to G5 scale, which is similar to the current hurricane category scale. The current solar storm has a rating of G4, marking it as the most intense event since late January of 2005 to strike our planet. Storms of this designation are classified as severe, often causing various problems to certain types of electronics. In a G4 storm, insufficiently protected satellites can be knocked out or even knocked into a lower orbit, certain radio communications can be disrupted, and scattered power outages can occur. While the current solar storm is indeed quite strong, it is not a huge cause for concern. So, why did we not find out about this expected solar storm until today? Unlike Earth-based weather, when monitoring the sun, we cannot actually predict what it is going to produce in terms of solar flares and coronal mass ejections ahead of time. Instead, we can only monitor such an event about 8 minutes after it already occurs. At that point, scientists can only give advanced warning of between 15 and 72 hours, with this marking how long it takes for the plasma to reach Earth's magnetic field. I hope that everyone who can enjoys the spectacular aurora tonight. Hopefully you did not mind this non-geology science video.